So one of the applications of systems of equations is what's called break-even analysis. So with break-even analysis, you've got two main equations that you're working with. One is your revenue function. And so this is the sale price of an item with an X. So the amount of revenue would be the sales price multiplied with the number of items that were sold at that price. The cost function is going to be fixed costs, and these are costs that are associated whether we make one item, 100 items, or 1,000 items. So this would be things like research and development, advertising, things of that nature, plus the actual cost of materials needed per item. So if we were making, say, sweaters, my cost per unit would be the amount that I spent in the yarn and the thread and the tag and the thing and the buttons and anything like that, where I could put that down as per item. Now, break even is going to be when your revenue function and your cost function are equal to each other. So basically what you're saying is you made enough money to pay off the cost for it, but that's it. There is no extra. You're not taking a loss, but you're not taking a profit either. Okay. Now, if we are going to talk about profit, the profit function is you take your revenue and you subtract your cost. Now, one of the things that people always think about when they think about profit function is it has to come out positive. And while that is true to actually say that I was making a profit, if you have a profit function set up and you were to get a negative answer, that means you were just taking a loss on the actual thing, on whatever that particular setup was. So now the example that we're going to look at is we have a company that manufactures running shoes, has fixed costs of $300,000. And again, that may be research and development, advertisement, anything of that nature. Additionally, it costs $30 to produce each pair of shoes. So that is the laces, the leather, the fabric, the soles, the whatever else. And then they're saying that they sell those at $80 a pair. So they want us to write a cost function and a revenue function. And then the next thing will be that we're determining the break-even point. So here we go. So the first thing is they wanted us to define a cost function. So we're going to have C of X. This was our cost function. And we said it was our fixed cost. And they said that our fixed cost was $300,000 plus the cost per pair of shoes. And they said they had $30 in materials that they were doing for that one. So there is our cost function. Now, our revenue function, this is our how much we're selling them for. They said that they were selling that for $80 for each pair of shoes. Now, this particular example did not ask us to do a profit function, but I want to show you something that when you're doing a profit function, which was revenue minus cost, this was the setup for revenue. What you're going to have here is, because this cost function has more than one piece, you would need to use a set of parentheses to make sure that you are showing that you are subtracting all of that. So you would have 80x minus 300,000 minus 30x, and we could combine the x's to get 50x minus 300,000. Okay, so this would be a profit. Now, again, the whole point of this is to show you to use the set of parentheses there. Now, they did ask us to do break even. Break even is when our cost function equals our revenue function. So if I take my equations that I have 300,000 plus 30x is going to equal 80x. I'm going to subtract my 30x. So I'm going to have 300,000 equals 50x, and then we'll divide by 50. And we're going to get that x is 6,000. Okay. So what that means is, if we interpret that, is I need to make and sell 6,000 pairs of shoes in order to bring in as much money as I spent. Okay. The other thing is that once we've determined this value, anything after this, so 6,001 pairs, 6,500 pairs, anything like that, is that we are going to be making a profit. Anything below this 6,000 means that we would be losing money or taking a loss on it.